Okay, morning guys. Okay, so today we are going to start one of the chapters of DP, but it can be used by DP students, DP1 students. It can also be used by IGCSE class 10 students, also by MYP5 extended students. Okay, the name of the chapter is logarithm. Okay, so now before we talk about logarithm, we must understand indices, correct? So we have read in our earlier classes, in our smaller classes, that a to the power x is equals to n, correct? Example, 2 to the power 3 is equals to 8, correct? So now here, what is a? A is known as the base, x is known as the degree of a, and n is the number or the answer, correct? So in this case, if you talk about 2 to the power 3 is equals to 8, and as an example of this particular indices, so we can see 2 is the base, 3 is the degree or the power, and 8 is the number, answer. So if you want to convert this particular indices to logarithm form, it can be done in both the ways. I mean, you can convert logarithm to indices or indices to logarithm. You have to write in this way. See, log of the number, base is a. So you write base here as this suffix. Okay, and remember in chemistry, how do you write suffix? Similarly, you have to write base a and x will be the answer. Okay, so degree becomes an answer. Okay. So how do you call this part? Log n base a equals to x. Okay. Here we call a to the power x is equals to n, indices form. The logarithm form of which is a to the power x is equals to n, where a will always be a positive number, but that will not be equals to 1. Why it will not be equals to 1? Because if you see here, converting this back to this one, so we can go in a reverse way as well, okay? If you come from here to here, you will see 1 to the power anything will always be 1, which does not make any sense, correct? You talk about 1 to the power 1, 1 to the power 2, 1 to the power 100, 1 to the power 999, anything, it will always be 1. So you cannot keep a as 1, okay? Also in the base change formula, we will see here that why a cannot be 1, because it will bring the denominator as 0, and we know that denominator cannot be 0. In functions, we have read that during our domain and range, correct? It means if I want to convert 2 to the power 3 is equals to 8 in logarithm form, how do we do that? We write log of 8 base 2. This base here will be base 2 is equals to 3, which means 2 to the power 3 is equals to 8. Make sense? So this way we convert our indices or exponents into logarithm. Okay. Now logarithm is written as log, and straightforward a number is written. For example, nothing but if I have written just 10 here, and base is not given. Okay. If base is not given, then it is always considered to be 10. Okay, if the base is not given, consider it to be 10. So the answer will become 1. Correct? So they can just go and see that what is log 100. So base is not given. So you have to understand that the base is taken as 10. So your answer will be what? 10 to the power, how much is 100? So say 10 to the power 1 is 10, 10 to the power 2 is 100. So the answer will be 2. Hope this makes sense. Okay? Okay. Now to the next part of logarithm, which is the properties of logarithm. Correct? Now these properties are very important, okay, because you know what, the questions in IB or in IBDP or in IGCSE comes in this way, that it's not necessary that in one question only one formula can be utilized. Okay, there can be like 3 or 4 formulas can be applied to a single question. Okay, so let's start with the properties of logarithm. Properties. Okay, let's see. So the first property of log say that log of a plus log of b is equals to log a into b. Okay, so log of a plus log of b is equals to log a into b. Remember, the bases have to be same. Okay, if the base suppose here is you can say x, the base here will also be x, the base here will also be x. Okay, the basis has to be same. Okay, then only you can do this particular, you can use this particular property. Okay, the second property says that log of a minus log of b is equals to log a upon b. Okay, again the same rule, it can only be done when the bases are same. Okay, suppose the base is x everywhere, this is base x, this is x, then in the answer also the base is x. Suppose it is 10 here, 10 here, so it will be 10 here. If they are not, the bases are not same, if it is 10 here, if it is 2 here, then you cannot use this particular theorem or this particular property. Make sense? Okay. Now the third rule of logs is log a to the power n, and suppose the base is b. Okay, remember it is only a to the power n and not the whole complete log a to the power n. Okay, it is only a to the power n. In that case you can bring this n which is in the power in a coefficient. Okay, you can bring it here, n log of a base b. So those who remember studying half-life in physics last year, atomic physics, there we have done this kind of formula, correct? In half-life, solving half-life questions. So this a to the power n, remember if it is log a to the power n, this cannot be written as n log a, okay? Only if it is n is in the power of a, then only you can write this particular formula, okay? So these are few mistakes that people do, just take care of this. What if the power is on a b? It is log b to the power n base a. So remember, if it is in the a to the power n, you put n in the coefficient. If it is b to the power n, which is power is in base, in that case it will be 1 upon n log of a, the base will remain as it is. Okay, so if it is here, so suppose if I combine both of them and if I write like this, log a to the power m b to the power n, this can be written as m upon n log a base b. Okay, these are the first 4 properties of logs. Make sense? The fifth property of the log says that log of a base b can be written as log a upon log b. So see here, you have the right to choose any of the bases. I mean, you can choose base of your choice. If you want to base as 2, 5, 10, anything. Suppose it is x, then you have to take base here also x. But this base can be your choice. Okay. So every student can have their own choice and you can put here like this. Okay. So log a upon log b and base x. This is known as base change formula. Mostly used in exams. Okay. Base change formula. Okay, so in DP exams, if you talk, mostly this formula is used extensively, base change formula in DP exams. Okay, okay. The sixth formula is log a by b. Okay, log a by b, whatever is the base. Okay, that base has to be same on this side also. This can be written as log b by a, but it will be a minus here. Remember, you can change the denominator and numerator, you can swipe it, but what will happen, minus is going to come on this end, okay, as a coefficient, correct? See, you have read about indices, correct? You can write log b by a to the power minus 1, this, correct? And by rule number 3, minus 1 can substantially be put in the part coefficient, correct? So minus 1 log b by a base x, okay now? So this is rule number 7, okay? So these are the rules of logarithm, okay, which will help us in solving questions. Okay, so just make sure that you do these kind of things. There is no doubts.